more complex equivalency. So it says we should now have a better ability to work with exponents. So in this lesson, we're going to talk some more about expressions that are equivalent, but we'll be sticking to linear expressions, okay? Those where x is only raised to a power of 1, and quadratic expressions. So that's something a little bit new, where x is raised to the second power, x squared. So it says recall that two expressions are equivalent if they return equal values, okay, when the same number is substituted into them. So we have the expression in exercise 1, x minus 2 times x plus 5. It is equivalent to one of the expressions below. So here's the expression, and this expression is either equivalent to x squared minus 10 or this trinomial x squared plus 3x minus 10. So let's see which one it is equivalent to. So according to this, it says two expressions are equivalent if they return equal values. So if we test x equals 3, so we could pick any number, it just happened to pick x equals 3, and we do that substitution. Whoops, sorry, something's going a little wacky with my stylus. Let's back that up. Whoa. Not sure what just happened. There we go. With my stylus, I apologize. Okay, minus 2, and then 3 plus 5. So when we evaluate that, we end up with 1 times 8, which is 8. So we've got to find which one of these is equivalent to 8. So if we take that 3 and plug it in for that, we end up with 9 minus 1, which is negative 1. Okay, we've got to get an 8. So let's see if this one produces an 8. Plus 3 times 3 minus 10. And we get 9 plus 9 minus 10. 18 minus 10 gives us 8. So our original expression is equivalent to the trinomial. Okay? So I'm going to have you do x equals 5. Let's hop down here and let's look for some patterns. Okay? We did this in one of the lessons with the commutative and the distributive property, or excuse me, commutative and associative property. So let's see what comes up with this. It says the steps in finding the product of this. So if we were to multiply, x plus 3 times x plus 5 are shown below. So they're writing down all the steps. It says write down the justification. So what property is being used in each step? So here's the initial problem, and then they've done some manipulation here. So how did it change from the left side to the right side? So if we take a look at this, we see that there's x plus 3 times x, and then we have x plus 3 times 5. So they took this binomial and multiplied it by x, and then they took the binomial again and multiplied it by 5. That's just a different way to use the distributive property that you just haven't seen so far. So now, how did we go from this step? Okay, there it is right there. They didn't change anything. They just rewrote it. So how did we go from the left side to the right side over here? So what happens? It looks like now we have x times x plus 3 times x plus 5 times x plus 3 times 5. Again, the distributive property. And then remember, this just gets rewritten down here. And what happened here? So we end up with, here's the same expression. Now what was done? We have x times x plus x times 3 plus 5 plus 3 times 5. Again, we just have another look at the distributive property. And here's our final answer. So they cleaned this up, they did the multiplication, and they did the simplifying. So if you take two binomials, x plus 3 times x plus 5, and multiply them together using the distributive property, essentially twice, we end up with that trinomial. So go ahead, let's flip the page, and let's practice this idea. So this is something, there's that word again, that we're going to have to become fluent in. So something that's going to become very automatic because you're going to need to be able to do it rather quickly. So let's try this first one. So I'm going to start with distributing. So x times x is x squared. Remember, we're multiplying. When you multiply, you add exponents. X times 3 plus 3x. Now I've got to distribute that 6 in the same manner. 6 times x plus 6x. 6 times 3 plus 18. Now to further simplify, I'm going to combine like terms. I just multiplied two binomials to end up with, that is my final answer in simplest form. Let's hop over to letter C and do the same thing. So x times x is x squared. X times negative 3 is negative 3x. Now don't forget, you've got to distribute that negative 3. So negative 3 times x, negative 3x. And negative 3 times negative 3 to finish it out is positive 9. Look for like terms to combine. And we've got our final answer. So I'm going to have you do B, D, and E to come to class with. I'm going to demonstrate letter F. So binomial times binomial, start that double distributing process for x times x. That's going to be 4x squared. 4x times negative 7. Remember, we're distributing, so it's all multiplication. Negative 28x. Now distribute that negative 1. Negative 1 times x is a negative 1x. And negative 1 times negative 7 is a positive 7. Combining like terms, 4x squared minus 29x plus 7 as our final answer. Okay. This one's pretty cool. It says Jeremy has noticed a pattern that he thinks is always true. If he picks any number and finds the product means to multiply, of one number larger and one number smaller than it, the result is always one less than the square of its number. Wow, we just said a lot there. So let's back that up. Okay, he picks any number. I don't know, I'm going to pick number 8. Okay, and let's see. He picks a number and finds the product of one number larger and one number smaller. So what number is larger than 8? 9. One number smaller than 8 is 7. And we find the product of those. So we just did all of this. So what is that product? It's 63. It says the result, the answer, the 63, is always one less than the square of his number. So if I take his number and square it, what is 8 squared? It's 64. Is 63 one less than 64? Yeah, that is absolutely true. All day, every day. And I put 2 E's on the end of my true. Let's take that off. All right, so it says now, try a different number if you're questioning that. Okay, try any number. Kind of cool. It says, give an algebraic explanation that shows that Jeremy's pattern will work for any number. Use let statements to clearly define your variable. So I'm going to let x equal my number. Okay. So it says here, so if x is my number, what is 1 less than x? X minus 1. And what's 1 more than x? X plus 1. Okay, x is my number. Take away 1 is less than it. Add 1 to it, and it's 1 more than that. Now let's take and multiply, because that's what we did up here. We multiplied our two numbers. So when we double distribute, x times x is x squared plus x minus 1. Combine like terms, plus x minus x, those go to 0, and I'm left with x squared minus 1. So what? You're like, where's the connection? Didn't we say back up here when we multiplied our two numbers, the result is 1 less than the square of that number? So isn't x squared minus 1 1 less than the square of our number? That's pretty cool. All right, I'm going to let you do number 5 and come to class with that. So let's hop over to our next lesson. So dealing with some more structure, I like to think about when they mention structure, we're talking about patterns, trying to see patterns in the math. So let's look at this. Okay, let's look at that expression. So when you examine that, hopefully you're looking for some patterns. You're looking for some things that are in common. And my eyes are kind of drawn to, I see there is an x plus 4 there and an x plus 4 there. So let's see if that does anything for us. It says, write an equivalent trinomial. Test the equivalency with x equals 1. Show the test. So if that's my original, and I go through, and I'm very tempted to double distribute here, okay? I certainly could do that and say, I shouldn't say double distribute. I'm going to distribute this first. X times x is x squared plus 4x. Now let's distribute that 2 plus 2x plus 8. And let's combine like terms. X squared plus 6x plus 8. And they're asking us, okay, so let's test x equals 1. So 1 squared, I'm plugging that into my trinomial. I'm substituting, I shouldn't say plug in. That's something we do with the outlet. And we end up with 1 plus 6 plus 8, which is 15. Okay, so we're testing our equivalency. So now let's take, okay, so that went into our answer. Let's put that 1 into our original problem and see if we come up with 15. So 1 times 1 plus 4 plus 2 times 1 plus 4. And we end up with, think order of operations here. Let's do those parentheses first. And we end up with 5 plus 10. There we go. So we definitely have equivalency there. Okay. Now, over here it says, write an equivalent expression that is in the form of the product of two binomials. So I need to write two binomials that's equivalent to this expression. And go back to what I said in the beginning that I have marked with my arrows. They have an x plus 4 in common. So what if I took those out? Because really that ends up being a common factor, greatest common factor. And then what's left over? X plus 2. So let's see if that's, oh, there goes my stylus again. Let's see if that's equivalent to, there we go. Let's see if that's equivalent to 15 when I type in, or when I substitute in a 1. Let's see if we get 15. 5 times 3, look at that. Pretty cool how that works, that equivalency works, finding patterns. All right, so let's take exercise 2 here, and let's get some more practice. So again, when you examine that expression, look for things that are in common. Look for structure. Look for patterns. So when I look at this group, and then I look at that group, what do they share in common? Okay, again, it's an x plus 4. It says write an equivalent expression that is in the form of the product of two binomials. So again, I've got to sort of simplify this crazy expression into two binomials. Well, again, what do they share in common? That is a common factor. Now, let's take it out. What's left? Okay, I'm going to expand my parentheses here because I got to write a little bit big. I've got to write some more stuff there. So I end up with, x minus 5 plus x minus 2. That's kind of messy. What can I do with that? X plus 4 looks great to me, but what can I do in here? I have x minus 5 plus, we're combining here, x minus 2. So what is x plus x? That's 2x. What's negative 5 plus a negative 2? That's negative 7. Do I have two binomials here? I certainly do. It says test the equivalency of x. Show your test. I'm going to let you guys test x equals 1 into that. Show me. And then over here, again, you've got to test x equals 1 into the original problem. And show me that the two are equivalent. Okay? Let's hop down here to this one right here, which is kind of cool, but it's a little dangerous, a little tricky, because we've got that minus sign in there. Okay, so let's be real careful of that minus sign. So again, examining it, do you see anything that looks the same? Look for the patterns. I see an x minus 3 and an x minus 3 that they share in common. So let's go from here and say, okay, well, they share an x minus 3 in common. So I'm going to take it out. Now, what's left over? So again, read from left to right. 2x plus 7. Don't forget that minus sign. And then x minus 4. And you must have all these parentheses. Now, let's clean it up. X minus 3, nothing to do with that. But now, 2x minus x. Let's be careful. 2x minus x is x. Now, let's be real careful with this one. What is 7 minus a minus 4? 7 minus a minus 4. Hopefully you're thinking in your head, well, that becomes 7 plus 4, because minus a minus becomes a positive. So 7 plus 4 is 11. Do you see where we had to be so careful there with that? So now, what choice do we end up picking for our answer is 2. Okay. So let's flip it over again, something that you want to become fluent with. I'm going to let you do A. I'm going to let you do B. That's a minus 1. Be careful. Okay. Oh, I like C. I want you guys to try C. And then let's hop down here. I will do D with you. And we're almost done. It's getting a little lengthy. So let's take a look. Let's find our structure or a pattern or something that's in common. And I see an x plus 3 in common. Cross them out. So we took care of it. What's left? Use the parentheses. X minus 6 plus x plus 9. So I have x plus 3. And now let's clean up. X plus x. 2x. Negative 6 plus a negative 9 plus 3. There we go. We have the product of two binomials. We simplified that. I'm even going to challenge you to do E. Be super careful with that negative. Okay? And I think what we'll do is we'll do 5 in class. Okay? So you do not have to do 5. Don't cross it out. But we will do in class as a group. All right? Take your time with the problems that you have to do. Go back. Rewind the video if you need to listen to pieces of it again. Don't get frustrated. You guys will do great, and we'll do lots of practice in class. See you later.